Good evening, everyone. I'm going to see where it is best for me to stand. Um, so today I'm going to be talking about design-driven science. You know, we live in a technology-driven world, so people say. But from the design community side, we should really look at it as a design-driven world using technology to actually solve the problems. So that is how we've been trying to shape our work in the technology area. Um, when I first got to Tupperware, we actually didn't have a dedicated R&D team, so we had to actually build it from scratch, which was both good as well as bad. Good because we could select what technologies and what type of competencies we wanted, and maybe a little bit bad because you couldn't get everything at once. You had to build it slowly over time. But our focus was to have an open innovation model. So those of you who are focused on partnerships will know that term. The important thing is that if you are working on a range of products and you are trying to build new products for the future where it encompasses new technologies that you don't currently have under your roof, in your toolbox of core competencies, you have to work with partners. And really, that's the fastest way to get there. And there are many advantages to working with partners. Number one, it gets your product faster to market. Number two, you don't have to climb the learning curve all the way from zero. And number three, it actually costs less money because you don't have to pay for development all the way from the beginning. You could leverage all of the expertise that your partner would have. So I'm going to first talk by explaining a little bit about the World Design Organization, and then I'll get a little bit more into the topic. The WDO, I mentioned this a little bit earlier this morning, is driven by the UN Sustainable Development Goals. We utilize this as a motivation to try to solve real-world problems. And we've got a number of projects that I will explain to you in just a few minutes. We have over 190 members. I think today it's probably upgraded. We might be 200 or over 200 members. And it is across 5 pillars. So we have professional associations, promotional associations, education members, corporate members, and then city governments. And generally speaking, according to the WDO, they have a reach of about 400,000 designers around the world. So the UN SDGs, again, the mission is to focus on how do we progress as a design profession from yesterday to today till tomorrow. It was interesting because when I first entered the design profession as an industrial designer, everything was about products, and then suddenly the focus changed a little bit. It became products and services. Today, you find that you actually cannot sell product if you're not willing to give away service as well. And then it focused on experiences, right? And now the big focus, for today and to tomorrow is looking at how do we utilize design as an opportunity and as a tool for social improvement. How do we use design to improve quality of life, however we define that? By the way, the UN SDGs, it's a really big opportunity for the design field. And the reason why I say that is because the UN SDGs in its current form was actually developed without input from design. It's something that the design profession has embraced, but it's only a 2030 initiative. So this is 2023. And so it means that it expires in 7 years. It's almost like tomorrow. So I think we have the opportunity now to take a look at what has happened and some of the thought process. Not only that, but a lot of the objectives like zero poverty, zero hunger won't have been close to being reached. So wouldn't it be interesting for the design profession to come up with a proposal to go back and say, this is what we would propose for the 2040 or 2050 initiative. What comes after the UN SDGs. Just really quickly, 4 recent projects that we worked on within the WDO. At the start of COVID, we worked with IBM on really a challenge on how do we live with the pandemic, because life changed, suddenly everyone was in isolation. So this was a really big project. Honestly speaking, whenever we start a challenge like this, we ask our members to sign up and volunteer. And then in addition, we open it up so that the rest of the design community around the world can also volunteer if they're interested. We ended up with, I would say, more than 5,000 requests to join that project. We were actually only able to pick maybe about 350 of them. So there was a lot of interest, and it was just a matter of being able to manage the volume of work that came through. But the beauty of this was that it was really a 24-hour project. When you went to bed at night, other parts of the world would actually continue working on it, so that when you came back to your office or your university the next day, it's already been around the world, and you have input from many other people that you otherwise wouldn't have. We also work with the United Nations. One of the things that I want to point out is that since 1974, the WDO has had official UN consultative status, which means that it's a recognized UN NGO. And it gives the WDO the ability to go in front of the General Assembly. And one of the things that has been created over the last couple of years is this, and some of you may have heard about it, it's called WDIP, World Design Impact Prize. We don't give an award for products, but we do give an award every term, so it's every 2 years, to the best product that's nominated that actually has the best impact on quality of life. And then we take that project and we bring it with us in front of the United Nations General Assembly so that we can actually show to the world how design can actually impact quality of life. It's a really great process. So with the UN Women, we focused on this generation equality. Really, how do you utilize design as a tool to solve for violence against women and girls? And they had never worked with designers before, so they fell in love with design. They collected 5 main projects from this challenge. If any of you are interested, you can actually go to the WDO.org website, and it'll point you in the right direction, because we're continuing to work with the UN Women on the next phase of it. They're not interested so much in a collection of loose ideas or concepts. They actually want something real. They want something to become reality, because that's the only way to actually provide a real tangible benefit, is to put something out in public. So we're working with them on that. We have had a project with the ISS National Laboratory. So this is really the CASES group, the Center for Advancement of Science and Space. And the focus was design in space for life on Earth, taking a look at the International Space Station as sort of a micro-community, looking at everything that's on there that is sustainable. They used to have this joke that today's coffee was yesterday's coffee, because everything gets reused. So just looking at what takes place over there, within that micro-community, and what can we bring down to Earth to really benefit all of humanity. That's one of the things we were focused on. The other thing that we wanted to look at as well was how do we give students and researchers more access to space? And this is really interesting because, even a concept of an orbital university came up as well. And then we also worked with a WPO, World Packaging Organization. They're a large group as well. A lot of packaging is very controversial because some of them have very limited life. You purchase something, whether it's takeout food or something from the department store, and you bring it home and it has a very limited life. What do you do with it afterwards? This was one of the things that they were looking at. Sustainability was only one part of it. The other part was safety. Especially when you look at medicines and, how do you keep pharmaceuticals out of the hands of children. So these were some of the projects that we've worked on. And then Perdimnia had mentioned yesterday the UN SDGs. So for those of you who are not familiar, definitely go and look them up. These are the 7 of them that were determined by the membership of the World Design Organization that they felt had the biggest impact, or rather that design could have the most immediate impact on in terms of the UN SDGs that were being proposed. You'll notice that the one on gender equality is not here, but we do work on some of these other ones that are not listed as well. All right, so I'm going to talk about design-led science and technology integration, and I'm going to give you some case studies from my work at Tupperware. Very interesting. The way that we used to work is that we had designers, I think a lot of companies don't really involve designers that far up front in technology development, but we actually had designers defining what technologies needed to be developed to solve the problem. It wasn't enough to say you've got a great technology. The question is, does it do what you want it to do to solve the problem? So I want to give you some of these case studies. Probably when most of you think about Tupperware, this is what you think about. Because this is the eco bottle that was actually developed, by the way, for the India market. But it caught on. Every country in the world liked this bottle. So we ended up producing it for any country that was interested. It turned out to be a big bottle-making opportunity. It wasn't something that we started out expecting, but at the end of this exercise, we ended up producing something in the neighborhood of 50 or 60 million bottles a year of this type and other similar types of designs. But the idea here was very relevant because the whole opportunity was don't buy single-use bottles with water in them. Refill your bottle and actually save on the materials and save on the planet. We do, Tupperware has a big presence in India. This is actually some photographs from our plant in Dehradun. The Tupperware plant used to be located in Hyderabad, but it had to expand because the India market was growing so fast. So the question was, is it possible to expand in Hyderabad? The answer was no, because it was basically landlocked in between other factories. So they picked Dehradun because it was out there. They had the opportunity to build a whole new campus. But they are extremely well versed in technology, especially injection molding, and they're really versed in things like 2 and multiple component molding as well. Highly automated factory. Really, I would classify it as state of the art, and it's here in India, specifically for the Indian market and adjoining countries. What makes Tupperware more let's say, favored than a lot of other housewares is because the products are designed for life. The idea here is that, every product that is sold by Tupperware has a lifetime warranty. Sometimes I get the question, well, what does a lifetime warranty actually mean? Working with a lot of technologists, you have to actually have a metric in terms of what does it actually mean. So for Tupperware, it meant that for whatever frequency of use, so if it's a lunchbox, you expect it to be used every day. Maybe for other items, it might be used maybe once a week. But for that type of cadence, with repetitive use, the idea is that it should last at least 50 years and not lose any functionality. So that's the definition of a lifetime of use. Otherwise, they take it back. And then the focus on the development is everyday good design, and this is something that I was really proud about when I was there. We didn't develop products to sit in museums. You know, there are a lot of products that you find in design museums. I think that Tupperware was very fortunate that a number of their products ended up in museums, but that was not the purpose of designing the products. The purpose of developing the products was to give the user as much benefit as possible. And we know that we gave as much benefit as possible if we could increase the amount of use. So we would, you know, our focus was to create products that would allow people to use them every day, maybe multiple times a day, you know, and as often as possible, because then we knew we were giving them really great value. So that was really the focus. So I don't know if we can turn this music up a little bit, but this will give you some idea about the current state of So you'll notice from this video that the big focus is on multifunctional use. You know, there was a time when there was going to be a new product out for every different function that you wanted. Now the big focus turned into, you know, how many additional functions can we actually put into that product? You know, even things that were not originally thought about, because there was a first step and then a second step to take a step back and see how much additional functionality we could put into the product without adding any additional cost. More time living, you know, there are two focus areas, you know, and we actually made a big play about this: time and space. You know, we could give customers more space because it's all about organization, but time is really one of the most precious resources. It's one of the things you never get back. You know, so if we can actually make things really convenient for the user, that saves them time, we're also giving them a benefit. So let's talk a little bit about design, because I know there are a lot of students here, and it's important to you know, share some of our design values, you know, things that we consider as we're developing products. So the first one is original thinking. You know, as we're thinking about how do we develop new products, you know, the idea should be original, something that doesn't exist, but some possibility to inject, you know, more benefit than currently exists as well. Confidence, you know, it's all about trust. People buy Tupperware because they trust the product. It functions the way that it was meant to be, and then there are no negative surprises. Desire, I think any of you who have purchased Tupperware know that it's expensive, you know, so it is an aspirational product, and we want people to be able to aspire to their Tupperware. Honesty, you know, again, this goes back to this whole aspect of functioning the way it was meant to be. You know, everything is supposed to be transparent, and there should not be any hidden surprises. This hint of surprise goes back to multifunctionality. It can do this and that, but it can do so many things more. Sophisticated simplicity. It can be sophisticated, but it can still be very simple to do. So, you know, elegance comes from that. Warm, inviting, and friendly. Something you want to touch, something you want to own. And then finally, quality. A lot of people buy Tupperware because it lasts a long time. You know, it's known to be a type of product that has the highest quality standards in the industry. Now, we sent all of our engineers and all of our designers to cooking school. You know, sometimes we feel that we don't give enough attention to soft skills. You know, it's like design, 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 design. But if you're going to be developing products for housewares or for the kitchen, you probably ought to know a little bit about what you're designing for. You know, so the idea here is to kind of go back and recollect that knowledge, both from a kind of practical and experiential point of view. And the beauty of this is that there's so many different cooking styles, you know, different types of cuisines around the world. So, you know, basically the designers got to pick which type of cooking they were interested in, and that could help, you know, launch a whole new line of products too. We had a whole lot of university collaborations. This one was actually with the Shristi School of Design. You can see that they're actually signing Tupperware. But really, really great project, you know, and I think we should probably do much more of this. And a lot of interns. You know, I love this picture because it shows really a big contrast, you know. We had students from India, students from Europe. Here's one from Italy, and you know, just round the clock. The focus was how do we give students at least 3 rotations, you know, so that the first time they're basically learning. They're like a sponge. If they come back for the second rotation, you know, then they can become a little bit more independent. If they can come back for their third rotation, then in our opinion, they're hireable, you know, because now they can actually function as a designer with the design process and thought process. How many of you do mind mapping? Okay, so that looks really good, you know, and mind mapping, I think, is really an underutilized tool, maybe because it's so simple. It's really simple, but it's so fundamental to what you're trying to solve. You know, you try to put in the middle of your mind map what you're trying to solve for, and each branch is an opportunity. And you cannot eliminate those opportunities until you've done your due diligence and you've actually looked at what are the outcomes and the possibilities, you know. So we had taught not just our designers, but also our engineers how to do mind mapping. So you can see there's a lot of the engineering in there as well. There's a track that looks, you know, if we're looking at how to store fruits with better conservation, you can look at things like temperature, humidity, gas, and so on and so forth, you know, and all of the science is then boiled down to a visual. So you can see that if you are able to eliminate oxygen or keep oxygen from penetrating, you know, you get rid of oxidation. If you can keep carbon dioxide inside, that's one way to keep oxygen out. You want to eject the ethylene because you don't want your fruits to ripen too quickly. And then you also have to control transpiration. So it's not just respiration, it's also transpiration, which means moisture, because otherwise it can dry out. You know, and then all of the science, honestly speaking, I think I had the best job because I didn't have to do any of the research, but I ended up getting to be the beneficiary of the research. You know, so when these projects were proposed, suddenly I knew that when you're looking at fruits, there are actually 2 classifications of fruits. You've got fruits that are climacteric. So climacteric fruits are fruits that when you pick, they continue to ripen. Non-climacteric fruits are fruits that when you pick them, they immediately go into decline. So they both have to be treated differently in terms of how you want to store them, right? And then we had all sorts of other tools. These are all risk analysis tools, taking a look at how to control risk before we move forward with them. So I want to show now some of the design-driven science and technology. This is basically designers coming up with, you know, the PRD, the product design requirements, and then finding technical solutions to bring back and actually solve those problems. So let's start out at really easy things first. This one was an interesting project on recycling. So if you have a lot of colored materials, I should actually give you a little bit of my background. I am a designer also. My undergraduate is in design, but then I shifted to engineering afterwards. I have degrees in mechanical engineering, but my PhD is actually in material science and engineering. So I am a material scientist as well. The interesting part of this is that when you take different colored pieces of plastics and you're trying to recycle them, what happens when you combine all the different colors? What happens is that you end up with a product that looks brown. That's why brown is one of my least favorite colors, right? Because it's a color that you use when you don't know what other color to use. But here, what we did was we played with master batch. Are you familiar with the term master batch? Master batch is how you colorize plastics. Not only colorize, but you can add functional capabilities to polymers as well. You know, so when you colorize plastics, you actually don't use colored plastics. You actually add in some concentrate, and the concentrate is called master batches. You know, so you can actually add in concentrates that are also antibacterial, for example, and you can get functional aspects. So in the master batch, what we played with was how do you control master batch so that all the colors melt at different temperatures? You know, and this was a big investigation because you know, to the color experts, it didn't make any sense to them, you know, why we would be pursuing it. But for us, it made sense because we didn't want a brown product. We wanted something that actually had visual interest, you know, and you know, this is only one color scheme. We came up with blue, yellow, and black. You know, I mean, just different possibilities. Super interesting because you only get this streaking effect when you have the different temperatures that activate at different times. Some people like it, some people don't like it. You know, for us, it was more an opportunity to, you know, explore, but also to you know, to give the opportunity to sell something that's a little bit different. You know, it's almost like a piece of pottery now. Every piece is just a little bit different than the next one. And our quality department hated it. And the reason why they hated it is because the quality people are taught to look at part-to-part reproduction. They want exactly the same part, right? That's how they gauge their quality. So this thing actually threw a whole wrench into that, but for us it was a great product. Here's another one. So before I came to Tupperware, I worked for General Electric Automotive, and I was responsible for front-end systems, including headlights and that sort of thing. So we were developing a new set of tableware. You know, and tableware, unless you do something special to it, you know, it's not always that interesting. It just sits there. So here was an opportunity. I actually hired one of the optical engineers that I used to work with and brought them into Tupperware just for this project. And again, this project was driven by a designer. The focus here was how could we utilize prisms like you would have in like headlamps of cars to maximize the visual effect, you know, to bend light so that you have areas of high illumination and areas of less illumination, but even more than light, how do we transmit color? You know, so each of these bowls actually only has one small ring of color, but you know, through the prisms, it just propagates throughout the part. You know, so it actually helps to disperse both light as well as color. You know, it turned out to be a great product for us. Want to talk a little bit about the microwave oven, because the microwave oven. How many of you have microwaves in your house? Okay, it should be almost everyone, because microwaves have extremely high penetration in kitchens everywhere around the world. Almost every household has a microwave oven. Now, the problem with microwaves is that if you ask people what they use it for, most people will tell you that they use it only for reheating, right? So that's okay, but it's an opportunity, you know, and we wanted to jump on this opportunity. How could we turn this appliance that almost everyone has into something that can actually cook food? And how can we overcome the expectation, how can we overcome the bad experiences that people have had using the microwaves to cook food? I think all of you have experienced poor quality food if you try to cook it in the microwave. You've had pasta that turns into rubber, maybe chicken that also turns into rubber. You've had bread that turns hard as brick. Things like that. So how can we overcome that and actually give good quality food using the appliance that everyone already has? So the idea is, how can we develop products to do that? So we started off actually very simple. This was a range of products that we developed during the time called Heat and Serve, and it had two really distinct functions, but it was really design driven in a very simplified manner. You'll notice that it has some strange geometry. There's like this mound at the bottom, and there's actually a technical reason why this mound exists. So if you actually, part of the research that was done in our kitchens was to line up cupcakes in a circular pattern and also one in the middle. And what we found out is that, a lot of people think that microwaves cook from the inside out, but they don't. They also cook from the outside in. And if you actually take a look at the doneness of the cooking on this range of cupcakes, you'll find that it cooks faster around the perimeter and less in the middle, right? So if you draw a histogram, like a bell curve, in terms of doneness to not doneness, you can almost transpose that exactly into your geometry. So the interesting thing was, once we were able to put this into play, you can just imagine if you were cooking a casserole and you were putting the casserole in preparation to be cooked in the microwave oven, you actually get even heating, because what we've done is we've cut down on the cross section of the part that cooks less fast, right? And then we also had this special valve. The special valve was a two-way valve. You find that when you are heating, you have to release gases because there's a buildup. But when you're cooling, you end up with a vacuum inside the container. So you have to be able to reverse the valve so that it can then allow air to suck in when the air is contracting, right? And between the two, it has to seal, because if you end up carrying this or putting this in your bag, it still has to be watertight. So, having to do that was quite a task, but it was a good innovation. Microwave steaming. So we did a play on microwave steaming, and I think those of you who are interested in materials and technology will probably appreciate this. Again, we were looking at quality of food. So part of our research led to materials that rejected microwave energy. So we came up with this design. It was a multi-layer design. It actually allowed you to cook two different types of food at the same time. So you could actually prepare your meal all in one go. You could have your meats on the bottom. You could have your vegetables on the top, or in reverse. And then we had this water reservoir at the bottom. And the water reservoir had exactly the amount of water you had to use, because everything was timed. You don't want to run out of water in the microwave oven, So when we presented this to senior management, it was like a total game-changing thing. Their question was, you're proposing a steamer for the microwave oven that doesn't allow microwave energy in. Doesn't make any sense. So we had to explain, actually, it makes a lot of sense. If you think about the quality of food, and you can imagine that in the bottom, there's actually holes in it. You see this cross-section? There are holes in it, so it works like a colander, right? So when you put this in the microwave oven, you actually activate the water really quickly. Within a minute, you're already boiling. Steam comes in, and your food cooks 100% by steam only. It doesn't cook at all by microwave energy, right? So you're converting the energy, you're driving the steam, and that's how you cook your food. And the quality of this is exactly like the quality as if you were steaming it on your stovetop. And then microwave grilling, you know, this was another thing we were chasing. You know, back when we were looking at this, it almost seemed like science fiction. You know, how do you get something from the microwave to be like crispy? And how do you get grilling in the microwave? So we played with metals. One of the, you know, this was a project that we actually worked with the Fraunhofer Institute in Germany. Have any of you heard of the Fraunhofer Institute? So they're really good in materials, and they're really good in technology. And they did this research project for us, you know, and the question I got was, I thought you couldn't use metals in the microwave oven. The answer is, you actually can. It has to, number one, be the right type of metal, and number two, it has to be the right type of geometry. Because if you don't have the right piece of geometry and you have a lot of sharp edges, you're going to get sparking. But if you are able to modify the geometry, you can actually overcome that. The other benefit is that metal naturally, you know, if you're using a special type of steel, naturally repels microwave energy as well. So what we did was we actually developed, you know, what you see at the top is actually high temperature silicone, and we buried in the silicone a special additive. It was a ferrite additive. It's a 3 blend. It uses 3 different types of metals. It's proprietary to Tupperware, but the benefit is that, you know, microwaves has 2 types of energy. That's why they call it electromechanical. There's an electrical component and there's a magnetic component, and you have to utilize the 2 to balance against each other. And there's really a great physical property that you focus on, which is called the Curie temperature. The Curie temperature is the temperature at which magnetic materials lose its magnetism, right? So you can imagine that when you are heating this up, the temperature curve, the temperature profile is very fast. Everything heats up, it reaches terminal temperature in under a minute. But then once it goes past that Curie temperature, it plateaus, you know, meaning that it de-energizes. And then once it falls then below that temperature, it re-energizes. So you end up with this kind of like sinusoidal curve, right? And why is this important? It's important because if you have constant temperature, you know, the whole point is, how do you control temperature in the microwave oven? If you're able to have constant temperature, then your recipe for cooking will always come out correct. If you cannot control temperature, forget about it. You know, you'll never get the same results. So this one was, you know, was really a great project for us. We ended up actually doing much better than if you were grilling on the grill, because here we grilled from 2 sides at the same time. You were grilling from the cover, and you were also grilling from the base. So I have just this quick video. Let me see. Sound. No. So that focused a little bit on lifestyles as well. Now I want to change direction a little bit and talk a little bit about sustainability, because that was a really big push in terms of our technology work as well. You know, how do we really look at producing products that actually save on the environment and save on the use of materials? So the first one is, how do we look at reducing food waste? You know, this was a project that I started working on the moment I got into Tupperware. I ended up being at Tupperware almost 20 years. But one of the key things here is that so much food gets thrown away. You know, if we could just make one small difference, by the volume of products that they sell, it could actually end up being a big impact. So one of the organizations that we used to follow was called the Global Footprint Network. This is an organization that takes a look at the health of the Earth in terms of its ability to replenish itself, right, as resources are depleted. And they're telling us that we are already behind the 8 ball, we're already late, right? And what they're saying is that if we continue to overproduce and overconsume, by the year 2050, we will need 2.3 Earths to maintain our current rate of consumption, right? So what this means is that we all have to look at how can we reduce and how can we change our behaviors. Because if we don't change our behaviors, it means that in the near future, the world will start experiencing great scarcity. So we look at data, you know, and if we look at North America, for example, 40% of all food gets thrown away every year. It's a huge amount considering how many people don't have access to food. If we look around the world, 1.3 billion tons of food are wasted every year worldwide. It's a huge amount. So one of the projects was to give a research project to universities and something that would allow us to capitalize and build it into a product. You know, we asked 3 land-grant universities. So in the US, they have what they're called land-grant universities. Land-grant universities are universities that are given land and money by the government to focus on agricultural sciences. So we engaged what was known as like post-harvest departments. You know, the idea here was how do we develop a product that allows us to keep food fresher for a longer period of time so that people have longer use and they don't end up in the trash quite so fast. Now, the interesting thing is that all 3 universities came up with similar conclusions, which we would expect if it was science-based, right? So that part was not a surprise. And you know, the conclusion was that you have to store food as if the food is still living. And they are, you know, they're living organisms, even in post-harvest. So a lot of consumers think you can just store the food just like your other groceries. But no, that's not the case. You actually have to allow them to exchange the gas, you know, normally carbon dioxide inside of the container, with fresh oxygen on the outside. So all of the science boils down to the size of the holes, the size of the openings. You know, and our design team kind of put this all together. It was arranged through the data into 3 categories. We had high breathers. These are the vegetables that needed a lot of exchange. You know, like broccoli, for example, is a high breather. Then they had low breathers, like berries, anything to do with berries. Strawberries, blackberries, blueberries are all low breathers. And then there's that whole area in between, medium breathers, you know. And the slider that was designed basically covers holes that are on the opposite side. So it allows the user to customize how their product works depending on what they put inside the container. So if it's something that requires, you know, heavy exchange, you would put it on open, or you could put it on half open or closed. We used to use text in our labels, you know, to describe the food. But when you sell in over 100 countries, it's very difficult to translate that many times. So we went, you know, in with icons afterwards. This one, I should tell you, was also a game-changing product. You know, when I mean, I remember I was only at Tupperware for 2 years when I proposed this product, but it was all based on the research, right? And speaking to senior management, you know, about this product, their comment to me was, you know, David, for decades before you came here, we were telling our consumers that the best way to store fresh food is in hermetically sealed containers. And we do that the best, you know? So I said, okay. You know, and their comment was, and now suddenly you come along and you want to put holes in them, you know? So I said, okay, but you know, you have to follow the science. I said, if we actually built this product, it would give fruits and vegetables between 2 and 4 weeks longer in terms of freshness and in terms of use. It sat for about 2 years before the head of global marketing decided to have a little bit of courage to try it out. But then when they actually allowed me to build this product, it became #1 selling product in the world for Tupperware for like 4 years after that. So let me just show you. Yeah. So you know, here are just some examples of what some of the consumers put into the product. Of course, as designers, we have no capability to enforce what they use or what they, you know, what they put in or what they don't put in, and consumers don't really care about the technology. They just want to know that it works. That's the most important to them. So here's a quick video to show you, you know, how this thing works. And we use broccoli because broccoli is, again, one of the highest respiring types of produce. So the elapsed time that you saw was in the number of days. You know, so this was a test over a 3-week period. But you can show the difference. You know, you could still see that something was happening in the container, but much slower than what was happening outside the container. We also did a project on cheese. Unfortunately, it's a little bit washed out here because the product is white. But those of you who are familiar with European cheeses, for example, you know, cheese, especially like in French cuisine, is so important to their cuisine. You know, in a lot of meals, they would skip their dessert so that they can have cheese and fruits at the end of their meal. And you know, when we first started this project, the idea was, you know, how can we develop a better cheese container that helped to, again, preserve the, you know, the quality of the cheese. And the funny thing is, you know, there's a cultural aspect as well. When I first started to talk to some of our associates across the ocean in Europe, you know, mostly in France and Germany, they would tell me that in the US, we don't really have cheese. You know, they said that our cheese is like Velveeta, you know, it's like fake cheese. You know, so they should lead this project. But, you know, it turned out that they really didn't, you know, look so much at the scientific portion of it. Because cheese, what happens is that a lot of European cheeses are very high in moisture. So they evaporate. What happens is that they condensate, the water condensates on the top, it drips back down on the cheese and then makes it very unappetizing. And cheese is considered to be a high value commodity. You pay a lot of money for it. You know, so if you can give them a product that can conserve cheese, it really can benefit them. So what we did was we actually worked with a material supplier to develop this grid that allowed, we call it MTVR, moisture vapor transmission rate. And you can design this depending on the type of material and the molecular structure and the thickness of the material. So, and the amount of area, you know, everything had to be sized for the volume of the container. So we had different size containers as well. This one kind of illustrates it. And so, you know, this became actually one of the top selling products in all of Europe for probably 2 or 3 years. The interesting thing is that it was able to remove all the excess moisture outside of the container. And it does it in a way that is such a simple physics principle, you know? And so basically, in terms of the physics, you move moisture from an area of high vapor pressure to an area of low vapor pressure. So it just works by itself, you know? And it's always the highest on the inside. Why? Because that's where evaporation is taking place, right? And you know, it was a product, again, such a simple solution to a product solution that just works. A little bit about this NASA project, because it's also one on conservation. You know, this is everything that you send up with NASA has a mission badge. So this was the PONS. The PONS stood for the Passive Orbital Nutrient Delivery System. So NASA came and wanted to work with Tupperware primarily because of two reasons. Number one, because of the long history of Tupperware in terms of food-safe materials. A lot of those materials were developed because of our needs. The second thing was because we focus a lot on conservation. You know, so their mission was, how do we grow plants in space in microgravity that would allow astronauts to grow, harvest, and consume their own fresh vegetables? And this is really important because if you take a look at how long astronauts are in orbit, it's longer and longer, even eclipsing a year now. And the type of food that they eat on the International Space Station is pretty much freeze-dried. You know, I had the ability to visit the Space Kitchen at Johnson Space Center, and I saw how the food was prepared. Basically, when an astronaut gets a call to go on a mission, they are sent to the food kitchen. They're sat down, they go through menus to find out what the astronaut would like to eat. And then their job after that is to take those menu items and make sure that the nutritional value is there. You know, and then they cook everything, they freeze dry it, they transport it to the space station, and that's what they eat. You know, so having access to fresh fruits and vegetables becomes more and more important. So this is actually what ended up being the final product, you know. I should explain a little bit that the design problem was really special in this case. If you are growing a plant on Earth, you have a gravity effect, right? So basically speaking, if you have a potted plant, you pour water into it, what happens? The water goes to the bottom and everything follows natural order. Natural order means a plant goes up, the roots go down, right? But in space, the problem is water wants to go everywhere. So how do you control it so that the water is only in the place that you need it to be and allows the plant to continue to draw whenever it needs the liquid? So we worked with a whole number of scientists, a lot of people who were experts in fluid dynamics as well. And we came up with really three scientific principles to make this work. Number one, specialized geometry. So specialized geometry was really important because you know that when you have like sharp inner corners, that's a good place for liquid to collect. And if you have more generous radii, it's where it releases, right? So that's one, specialized geometry. The second one was surface energy. You know, so you could change the energy of the surface as well. The higher the energy, the more it wants to stick. The lower the energy, the more it wants to repel, right? And then the third one is capillary action, so capillary forces. So using all three of those, we were actually able to control it. This one ended up going to the space station on 4 experimental trials, and I believe that it's now finally approved equipment, which is really important for Tupperware because if they end up, you know, depending on where NASA wants to go, if they end up going to the moon or they end up going to Mars, Tupperware will go with them. No. So if you want to know more about this project, you know, please go online. You can even go to the NASA website. But I mean, there's so many places you can go. If you just Google both NASA and Tupperware on the same search line, you'll come to our project. And this was partnerships between NASA, Tupperware, and TechShot. So TechShot was the implementation organization. We were making a presentation before the first launch that went up on a SpaceX. And here we are showing it with an astronaut actually testing it on board the International Space Station. It was really a great exercise. You know, we were able to do what was called an on-console meeting with the astronauts as well. By being at Kennedy Space Center, we were not allowed to talk to the astronauts. We had to feed our questions in with someone who was actually in contact with them, but we were able to give them some guidance. Could we have sound?
Tupperware has been locking in freshness since the mid-1900s, and it recently used its expertise on the subject to help develop a better way to grow vegetables in space. Astronauts aboard the International Space Station, or ISS, have been cultivating leafy greens to supplement their diets, but the current means has shown there's room for improvement. Issues with the growing system largely involve hydration. The watering means relies upon pillows that must be filled with a syringe, and unfortunately, not all plants have responded well to that method. Tupperware was consulted in the development of an alternative. NASA reports the new system requires less crew maintenance and uses absorbent mats that leverage the basic principles of surface tension and capillary action to wick water to seeds and roots through a reservoir system. This approach passively disperses water evenly through each plant cylinder contained within the reservoirs, facilitating consistent seed germination and seedling development into mature plants. 7 of the updated growing environments will be part of SpaceX's next ISS supply delivery.
Okay, thank you. Yeah. So the next project I want to review is how do you solve against water waste? Because, you know, water is becoming a really important element for human consumption and human life. And so we wanted to focus on water. And one of the things we did was, you know, again, if you look at the statistics, 1.8 billion people live without access to safe drinking water. You know, so for us, it was also an opportunity. And then we have this Hall of Famer astronaut named Story Musgrave. So he was an ex-astronaut. He actually held one of the records for spacewalks, and he was also in charge of fixing the Hubble telescope during the time that it actually needed to be repaired. So he worked with our R&D team. He was only able to give us 1 day a week, but he came in for like 5 years to work on water projects. And you can see this is him today. And you can see that he was focused on this water purification system since 2009. And we actually ended up with a NASA solution. You know, this is the product that ended up working. It used a nano-ceram wrap, which means that it had basically a ceramic barrier with nano-sized holes. And the beauty of this is that you actually don't have to introduce any chemicals at all. No chlorine, no bromine. Because of the size of the holes, it just separates pathogenic activity, bacteria and viruses, out of the water mechanically, right? So it's a very clean solution. And because it's so clean, this is a product that actually takes, you know, not only the bad stuff out of the water, it takes the good stuff out of the water as well, the minerals. So we actually put in the return valve another enhancement tank using this special rock from Japan. It's called Bahukan rock. It's the only thing that is actually certified by the Japanese government for releasing minerals back into water, you know, so that they can get their minerals back. The interesting thing about this project is that it was hugely expensive. Every market that I spoke with at Tupperware wanted something different. So at the end of the collection of research, you know, I came back to them and I said, okay, I've got a solution for everyone, but it's not going to be cheap. It's going to be about $1,000 in retail, you know. So I I think for automotive, it's a small amount of money, but for Tupperware, it's a huge amount of money to expect people to spend $1,000. So I said, do you want us to move forward with it or not? So there were two markets, China and Malaysia, that basically said, well, let's give it a try. So I said, okay, I need to have a forecast. How many units do you think you can sell? And they said, well, put us down for like 2,000 units. And at Tupperware, as you can imagine, unless you have already a start of a few million units, you normally don't even go into industrialization. But for 2,000 units at $1,000, okay, still a $2 million piece of business. We said, let's give it a try. So we built it, and every year it has outsold what the forecast has been. And by the time I left Tupperware, it was actually the #1 selling product for Tupperware everywhere around the world, which is really amazing when you think about it, because Tupperware is known for food storage. It's not really known for water, but yet here you are with water filtration, and it has become the top-selling product. Now, I want to show you a project that really will be super interesting for all of you, and that is, how do we go to the next step? How do we really save water for people, for the earth, and for the environment? So again, looking at statistics, 63 liters of water is used in one hand wash application. And actually, if you're a person who likes to wash with the water running a lot, you could be using up to 150 liters. It's a lot of water that you use in one wash, versus using a dishwasher that uses much less water. So this is a real opportunity for us. And the thinking here was, okay, what I gave to my team was, let's go bold. What can we develop for Tupperware that will save the maximum amount of water? And the idea was the maximum amount of water is 0 water. How can we develop a product that never needs to be washed because it never gets dirty? So it's like, wow, that's reaching for the skies. But let's give it a try. We've got good competency. So we looked at different technologies, and we focused finally on the lotus effect. So the lotus effect, you've all heard about the lotus leaf, right? So the lotus leaf is the most superhydrophobic substance in nature. So superhydrophobic, which means that it repels water extremely efficiently, right? And if you take a look at this blow up down here, it's actually a micro-nano structure. And you need both of these types of geometry, micro on the bottom, nano at the top, in order for this effect to actually happen. So this was a big opportunity for biomimicry. How do we create something that works like a lotus leaf? Our metric was the contact angle. So contact angle measures the amount of superhydrophobicity that actually happens on the surface of any material, any substance, right? And the highest you can get is 180 degrees. 180 degrees is perfect because it means that the shape of your bead of water on the surface is a perfect sphere. If we look at a lotus leaf is 170 degrees. And I'm going to give you another reference point. All of you have probably used non-stick cook pans, right? With Teflon on it. Teflon-coated pans only has 90 degrees. So there's a big difference between 90 and 170, or ultimately the 180. So we set out on this objective. How can we get much better than Teflon? How can we get up to a point of the lotus leaf? So we utilized a combination of technologies. We tried each one by itself, but it turned out that actually the final solution was something that incorporated several different technologies. Some of it was surface finishes, some of it were textures, some of it was materials that you were molding it against, some of it were additives, just different types of actions that you would do to the material. We were able to get up to 150 degrees. So 150 degrees, is amazing when you think about the substance being something like polypropylene, you know, which is a much more common commodity. It's a polyolefin material. But you can imagine all of the benefits that you can get if you could solve it, you know. So for example, glues that don't stick, honey that if you use it in an implement, the honey would just run clean, right? It sounds like science fiction, but it's really all based on science. Or sticky sauces, you know, that don't stick to the walls. It just all comes down. So this was our experiment. These are two pieces of polypropylene. The one on the left with the red color, so we put a little bit of color dye into it because we wanted to make sure that we could tell the difference and which one was which. The one on the right, you know, so you see untreated, and then we had the Lotus treated one on the right. And then you can see with the honey put down. So the one on the left, you know, basically it sticks as you would expect. The one that's Lotus treated just rolls right off, right? So we were, you know, looking at how do we implement this science into real products, you know, and you can see our next testing was to actually put it into forms, and you can see that, you know, over time you could actually get to where you are looking to actually accomplish it. Just some last thoughts here. You know, designing products. We're designers, so we do want to focus on how we apply our designs. You know, we did a whole range of products with wood, you know, and this is super sustainable because we didn't cut down any trees. We actually saved or rescued wood fibers from lumber yards, the wood that would have been otherwise thrown away. You know, we would clean it and then we would put it in here. The real science was how do we get it so that the wood doesn't stick out. You know, a lot of the wood becomes like fuzzy if you wash it. So we actually coated it before we compounded it, and this was a really good opportunity to make a product that lasted a long time even with natural materials. And then we use a circular polymer, you know, with Tupperware or with any product that has to hold food. You cannot just take post-consumer product, regrind it and reuse it. And the reason why is because you don't know what has actually been put into those containers. You don't know whether it has been food or whether someone used it in their garage. So here was a method where you actually break down the polymer, you know, back into its monomers, and then you rebuild the polymer. So you actually get a new material from the old material. And our first use were on coffee mugs, you know, because so many coffee mugs are just single use. So this was an opportunity to get something much more sustainable. And the circular polymer could just be used over and over again. It is today still a more expensive process, but at Tupperware we wanted to put a line in the sand, so we were going to do it anyway. And then finally, you know, we also took a look at recycled bottles, and we made all sorts of bags from them as well. But again, looking for second and third uses for the material. Patents are really important, and I just wanted to give a feeling of how important they were. At Tupperware, by the time I left, over 46,000 patents around the world, where over 90% of them are design patents. You know, and the reason why is because for long-lasting products, the design becomes synonymous with the brand. So we don't want anyone just taking it. And yeah, just a couple statements. A modern future can't, you know, we can't develop products without materials and technologies, but we need to make sure that they're sustainable for the coming generation, right? Someday our kids will inherit the world. They need to make sure that they can also have a world that still lives. And then something that's super important, we always felt that tomorrow is more important than today. And that's why it's important to do all of that sustainable work. Finally, I want to invite any of you who are connected to WDO or who want to be connected to WDO. We have our World Design Assembly in Tokyo at the end of this year. This is where all the members of WDO come together. and have really great dialogues on the future of design in terms of education, in terms of collaboration, in terms of what's the best use of design. This is the logo that was actually developed by the same designer that developed the graphics for the Tokyo Olympics. So this is some of his brochures and things like that. But I just wanted to point out, the theme for the World Design Assembly is Design Beyond, and it's formed by overlapping multiple irregularly shaped colored surfaces so that it embodies a harmonious design. And it looks like an egg, which is a symbol of life and its rebirth. Really good philosophy. So anyway, anyone who's interested, that happens in October of this year. So that is the presentation. Thank you.